In this Grasshopper script, you can make a series of Voronoi cells and openings using this Voronoi on Surface tool. I'm going to explain step by step each of these inputs and outputs. Also, you can access the algorithm to know how we did this in Grasshopper. So first of all, what you have to do is to give this a base surface. For example, if I draw a surface in Rhino, this can be a flat surface, for example, this 4-point surface, and set this to the surface. Then we can control the number of panels we need. Basically, this is the input of the Voronoi cells numbers you can have. A UV input, which you can control. Basically, changing this number will give you more of a random result. So this can give you different results by changing the UV count. Then the most important part is the attractors. If you don't give any attractors to the input, what's going to happen is that you have a control on the height and the scale. Basically, the minimum height and the minimum scale will not work when you don't give any attractors, and only the maximum height, which you can see here, and the maximum scale of the openings work. So this is obvious because you don't have any attractors to define minimum height or minimum scale. So this is the first step if you don't want to give any attractors. But for example, if you want to use the evaluate surface to define a series of point attractors, I can give that to the point attractor. And as you can see here, I can change the location of the attractor. This attractor is going to, for example, if I just delete this and have one point attractor so you can understand exactly what's happening, I can give a minimum height, which is this, and a maximum height, which is going to define the maximum height of the Voronoi cells. You can also change the minimum height and maximum height. For example, if I give this a bigger number and the maximum height a smaller number, you can see that the point attractor is actually giving it more height at the location of this point. This is also a useful tool if you want to change the minimum height and the maximum height. If I want to also give a Nurbs surface to this, I can. Assume that we have this freeform surface. If I give this to the input, you can see that also it's going to affect the results. It's going to move those cells in the normal direction. Basically, the maximum and minimum height is going to be in the normal direction of the cells on the surface. Again, let's go to the input of the attractor. If I want to use this as a curve attractor, what I can do here is to go to the curve inputs and use a spline curve on surface tool. And obviously you can give it to the base surface and reparameterize it so it's between 0 and 1 for the UV dimension. And then you can use these MD sliders simply by searching for MD slider, giving it to the UV input. Remember that these points has to be in different locations so you don't get any errors. And now by changing the location of the points on the surface, you can see that I can get different results basically on the curve attractor. So again, let's just take a look at the inputs, the number of the panels distributed on the surface, which I can increase or decrease. A UV random generator, so you can change that if you want to. The minimum height and the maximum height based on their distance from the curve attractor. So the minimum, if it's 0, those cells are going to go down. And if I increase the maximum height, it's going to go in the normal direction. Again, I can change the minimum scale and maximum scale, just in reverse that. So the further we go from the curve attractor, the smaller it gets for the scaling. Also, if you want to make flat Voronoi cells, just decrease that maximum height to 0, so it doesn't have any height, and it's going to only affect the scale. Okay, so this can affect the scale here. For example, I can make that smaller and bigger. And this is also useful if you want to use it in your projects and make a flat Voronoi cell. Okay. The output here is the openings and Voronoi. I can bake that. For example, this one into layer 1 and the openings into layer 2. And as you can see here, we will have the mesh. This is the mesh that you can use. If you want to connect them together, you can simply do that in Grasshopper or just select the layer you want and join them together. It's going to give you a single mesh. You can also do that in Grasshopper, and then the layer 2 is the windows or the openings, which you can use for the Voronoi cells. If you go to the zip file, you can also file an algorithm. So if I open that in Grasshopper, I will have all the steps we have taken to produce that in Grasshopper. You can also learn it by looking at the components we have used. And as you can see, we have the surface here, the number of count, the UVs. If you want to use a point or a curve attractor, I have put that here so you can connect that to the geometry here, which we switch between them. Also the minimum scale, maximum scale, the minimum depth or maximum depth if you want to. And finally at the end you will have the windows or the openings here as the surface, and also the mesh, which is the cells for the output. If you want that in one single output, you can simply just go to the mesh, and in the mesh utility you can find this mesh join tool. Simply just give that and flatten it, so all of these meshes like 398 convert into one mesh as an output. And finally you can bake that in Rhino and have a single mesh surface. This is also great if you want to export it into other softwares like 3D Studio Max and those things. So that is a simple join tool. Okay, thanks for watching. If you have any questions or requests, just ask below this video or on our website. Have a great day. Bye.